Hi there, so this is Mr. Lovett, and we are going to look at mechanics today, and specifically we're looking at motion, and we're looking at linear motion in particular. So we're looking at linear motion. But before we talk about linear motion, I want you to understand the two different types of mechanics. You have the kinematics and dynamics. So we have kinematics, we have dynamics. So in kinematics and dynamics, we have this man studies or motion without considering the cost of it, what cost it. But this man studies the cost. So for example, if I'm running to school, kinematics concerns what time did you take to come to school? What speed were you using? What distance have you covered? That's kinematics. You want to understand the motion like that, describe that motion. But for dynamics, what caused you to start running to school? What is the force that was responsible for it? That's dynamics. So, but linear motion we are trying to look at is under kinematics. Now, so linear motion goes into two directions. So it's a motion along a line. Which it color. So it's a motion along a line. So this man comes now we have it's a motion along a line. And this line may be straight line or curved line. When it's straight line is rectilinear. When it's curved line, we call it curvilinear motion. Okay, curvilinear motion. So that's it. So we talk about straight line, rectilinear, and that. So our focus, it's here. And because our focus is on the straight line motion, so the straight line, so in the most textbooks you will see that a linear motion is a motion in a straight line. And we're mostly focusing on the straight line motion. And to talk about the straight line motion, there are four things that we need to always describe, because we say kinematics, linear motion is under kinematics, and kinematics describes a motion but does not care about the cause. And there are four things that we always need to use in describing motion. One is displacement. We have velocity. We have time, and we have acceleration. So you're expected to know how to define these various terms. You have displacement or distance, as you say. I have velocity or what? Or speed. So I need to know how to define these things. And we say the first one is displacement. Displacement. So what is displacement or distance? Therefore distance. So it's a distance, a separation between two bodies, right? So you have distance A to B. The distance between these give you displacement. But a distance and the unit here is meter. Now displacement is distance in a particular direction. This man is a scalar, this man is a vector. And so it's either moving to the north or moving to what? To the west. So it's a separation between two bodies in a particular direction. That's what displacement is. So it's the same thing, but you have to be mindful of the direction. You have to be mindful of the direction. So A to B is different from B to A. So there are two different things with respect to displacement. Now, the next thing we want to look at now is velocity. So what is velocity? So speed or velocity. Speed is a change of what? Distance on time. Change of distance on time. And velocity is a change of displacement on time. So we have the distance that we have used was I started at 0 and I'm at 20 meters. So the 20 meters on the time that I've taken was 10 seconds. And we're going to have what, 2 meters per second. So that's like so the time distance covered by the time taken is what we call velocity, or it's for speed, and the distance, the displacement covered during the time taken is what we call velocity. And this might be a vector, and this might be a scalar. And their unit is meters per second. So take note of that. Their unit is meters per second. So you need to know how to calculate this, and you need to understand what's instantaneous speed or instantaneous velocity. What is instantaneous? The speed at that time, at the moment. As the name says, instantaneous, the speed at that time. Then when we talk about uniform velocity or uniform speed, it means that the speed is what? Is changing constantly. Uniform means that it's the same, it's constant, right? So uniform velocity means constant, not changing. Not changing, or is constant, or constant, right? And we also have acceleration. So let's look at acceleration. So acceleration now, it's acceleration, say it's equal to change of velocity on what? On time. So we have like v minus u on what? C, which v is the initial final velocity and u is the initial velocity. So I started with this velocity, now I'm on this one. So that's how acceleration is done. And the unit for acceleration is a vector, and its unit is meters per second squared. That's the unit of acceleration. So you need to take note. You also have instantaneous acceleration, have uniform acceleration. So it's a uniform acceleration, it means it's constant. An example of uniform acceleration is the acceleration due to gravity. That will have g is always equal to what? 10 meters per what? Second, or 9.81 meters per second squared. So this is an example of a constant or uniform acceleration. It means that it does not change. It does not change. And instantaneous acceleration is acceleration at the moment, at the instant, right? So you need to know this from these various units and stuff like that, how to calculate them. So those are the main important things under linear motion. So in every describing any motion, you need to talk about the time. You need to talk about the distance covered. You need to talk about the velocity, whether it's increasing, decreasing, or it's uniform. Talk about the acceleration. You talk about whether it's increasing, is decreasing, or it's uniform. So these are the words we need to talk about. So if you watch the other videos, my videos on graphs and on how equations of motion, you will understand now how to solve equations using these various physical quantities. So you have to talk about, once it's describe motion, I want to hear about your time, the distance you covered, the velocity and acceleration. So they'll be giving you graphs and asking you, describe this graph. Describe the motion of this graph. So they want to describe the motion of the graph. What they're expecting to hear from you, actually, it's, well, how was the velocity? Was it increasing? Was it decreasing? Was it uniform?